Today's lesson is an introduction to Topic 5. Make sure that at the top of your Cornell notes you have written your topic objective, and also please make sure your paper includes your name, your class period, and today's date. So our topic for today is solving one-step equations. Now this should be a review because I know that you did this work in 6th grade, and we are aiming to answer one essential question here. How do I solve a one-step equation using inverse operations? So let's get your paper titled and then we'll get started. Before we can answer our essential question, we need to address a couple of other things first. Number one, what is the difference between an expression and an equation? Now you might recall that in topic 4 we did expressions. And now that we're entering topic 5, we're going to be transitioning to equations. And there is a key difference between them. The question is, do you know what that difference is? Well, let's take a look at that. An expression is one or more terms that could be connected by an operation. An operation means addition, subtraction, multiplication, or division. An equation, however, is a number sentence that shows two expressions are equal. So what that means is we might have expressions like this, or we could have equations like this. And what do you see is the biggest difference between the expressions in the list on the left and the equations in the list on the right? Well, the difference is that equations always have an equal sign. So you'll see that an equation shows that two expressions are equal to each other. So you have expressions here on the left of the equal sign, and you have an expression on the right of that equal sign. And the equation puts an equal sign between them. Once we see that equal sign, then we can work to solve an equation to find the missing value that is represented by the variable. The second question we'll answer is, what are inverse operations? Now, these go all the way back to probably 1st grade. You actually learned inverse operations as you studied your arithmetic, your addition and subtraction facts, your multiplication and division tables. And when we talk about inverse operations, we're actually talking about fact families. So inverse operations are actually operations that simply undo each other. So thinking back about what you learned from fact families, back beginning in probably 1st or 2nd grade, you learned about addition and subtraction first. They create a fact family. And the reason is because addition and subtraction undo each other. So we might have an addition sentence that looks like this: 2 plus 4 equals 6. But we can turn that addition sentence around into a subtraction problem and say 6 minus 4 equals 2. And likewise, we could make another addition sentence, 4 plus 2 equals 6, and we can make another subtraction sentence, which is 6 minus 2 equals 4. So you have 4 number facts that all contain the same 3 values, and you've used 2 different operations to represent the relationship between them. You can also do this with multiplication and division. Fact families with multiplication and division look very similar to the fact families for addition and subtraction. So a multiplication problem that says, let me try that again. There we go. That says 3 times 5 equals 15 can also be written as 5 times 3 equals 15. And likewise, we can change those both into division sentences, beginning with the product 15 and dividing both by 5 to get 3, or dividing by 3 and you get 5. So what we see here is that there is that same relationship between multiplication and division using the same 3 values and the 2 different operations. One operation undoes the other. So when I multiply, the inverse operation is division. When I subtract, the inverse operation is addition, and so on. Now go to the back side of your paper. Now let's talk about the actual solving process. In order to solve an equation using inverse operations, you need to first identify what is the operation in the equation. In other words, what's being done to the variable? Because the variable is like that mystery box that you used to see in your math problems in grade school, in elementary school. And those mystery boxes were always, what's the missing number? So let me show you an example of how it would have been written in elementary school, and then we're going to do the exact same thing, but algebraically, for middle school. In elementary school, you may have seen a problem that looked like this, where you have a blank box, then you see an addition sign with the number 4 equal to 10. And the question was always, what goes in the box? Well, in algebra, we now write that using a variable instead of a box. But we can solve it in very much a similar fashion. So again, going back to elementary school, what you see here with a box, you could have rewritten that problem to say, well, 10 take away 4 must equal that box because that's what the fact family says. And likewise, in algebra, we do the same thing. The difference is that we use an equation and we keep it balanced. Okay, the equal sign is kind of like the balance on a balance beam. It's the balancing point. We call that the fulcrum. And what we do to one side of an equation, we have to do to the other. So if I'm going to subtract 4 from the 10, that means I'm also taking away 4 from the other side of the equation. And what that does is it creates what we call a zero pair, because a plus 4 and a minus 4, or a positive 4 and a negative 4, makes 0. Now, by taking the 4 away from both sides, I've kept the equation in balance. The y on the left now equals whatever 10 take away 4 on the right is, which in this case we know is already 6. So let's look at some rules for solving equations. The biggest rule is this: whatever you do to one side of the equation, you must also do to the other side. There are basically 4 steps in solving any one-step equation. Let's look at these one piece at a time. The first step is always write the equation. So you may have to copy this down on separate paper. Here's another example. A minus 1 equals 10. The next thing that you need to do is draw a line at the equal sign. I'll show you what I mean. So we're really going to make more of a T-chart here. We're going to draw a line down and we're going to draw a line across. We kind of make it look like a balance beam. The third thing that we need to do is we need to undo the operation using the opposite. So in other words, the opposite of subtraction is addition. So we're going to undo the operation here by adding to both sides. And what we're adding is the number that's next to the variable. In this case, the number is 1. So we're trying to balance those out and make 0, which we did. And A is equal to 10 plus 1, which is 11. So the last thing that we need to do is actually compute. You can use a calculator for that, of course, if you need to. So the answer to the equation A minus 1 equals 10 means that A must be 11. Now let's try a few more questions together. Try the multiplication equation 5x equals 20. In this equation, we know that the operation is multiplication. We're still going to do something to both sides, but this time we're going to do the opposite of multiplication, which is division. So I'm going to divide both sides by 5. Why am I dividing by 5? Well, because I don't want to know the value of 5 x's, I just want to know the value of 1x. So 5 divided by 5 equals 1. And 20 divided by 5 equals 4. So in this problem, x must be equal to 4. We also have division equations, and you'll see that the division equations are often written in the form of a fraction, like so. In this equation, we're still having to undo the operation, but in this case, we have to undo division. Well, we undo division by using multiplication. So we're going to multiply both sides by the number in the division problem, which in this case is 3. And multiplying and dividing by 3 both provide for us the same answer, which in this case is just C. And C must be equal to 7 multiplied by 3, which is 21. Because 21 divided by 3 equals 7. That takes us back to our original equation. Take a minute to copy down these 4 equations. We're going to solve each of them using the process of inverse operations. Let's start with the first equation that involves addition. E plus 2 equals negative 5. So the first thing I'm going to do is I'm going to draw my line coming down from the equal sign. I'm going to make my little balance there. And I'm going to do the same thing to both sides, which in this case is I need to undo the adding of 2 by subtracting 2. So my variable E is equal to negative 5 minus 2, which is negative 7. Now let's try the second equation. This one involves subtraction. In order to undo subtraction, I need to do the inverse operation, which is addition. So I'm going to undo subtracting 11 by adding 11 to both sides. This time, n is equal to negative 7 plus 11, which is 4. In the third equation, we have multiplication. In this multiplication problem, we need to undo that multiplication where it says times negative 8, and we need to do that by dividing both sides by negative 8. And that division of negative 8 divided by negative 8 equals 1 v, which is all we want. We don't want 8 or negative 8 v's, we just want one of them. And we do that by computing 40 divided by negative 8. Remember that when you see something in the form of a fraction, like right here, that 40 over negative 8 means 40 divided by negative 8. And 40 divided by negative 8 is a negative 5. In the very last equation, I'm actually going to write this one down again so that you can still see the original equation and understand what I'm doing. I'm going to first undo the division. Undoing the division means I need to, I'm going to change that color. I need to multiply on both sides. And the number I'm multiplying by is the number that's in the division, which is -9. So -9 in the numerator and -9 in the denominator equal 1. So that tells me that W equals the product of -3 times -9, which is a positive 27. All right. Make sure that you have shown the work on all of your equations and all of your notes here on your Cornell Notes paper. We're going to be doing some examples together in class, and we are going to focus on all 4 operations. So having your notes out and having them completed with all the work will be extremely helpful. And then you'll be ready to try some equations on your own.